Let's solve first exercise. In the first exercise, we have the mailing cylindrical tube. The cost of the end caps will be 28 ringgit per meter square. The cost of the sidewall will be 80 ringgit per meter square. To find the minimum cost of our mailing tube, we should find first the areas of the sidewall, area of the end caps, which is 2p rh and 2p r square. But we don't have our radius and our height. Then we should find them. Before that, we have the volume, which is the formula of the volume of the cylindrical mailing tube is p r square h. The volume is fixed, which is 0.010 meters cubed. So when we derive the formula in terms of height, the height will be volume per p r square, which is 0.01 per p r square. So to find the minimum cost, we should multiply our sidewall cost to the area of the sidewall and the cost of the end caps multiplied by area of the end caps. And we just substitute our given values into the formula, which is 18 2p r h plus 28 multiplied 2p r square. We don't have our radius, but we have the formula of our height, which is 0.01 per p r square. Then we substitute into the formula, which is 18 multiplied 2p r multiplied 0.01 per p r square plus 28 2p r square. So here we don't have the height, that is why we just leave it like this. This one is our function. So we should differentiate our function to find our stationary point, which can be maximum or minimum. So first of all, we differentiate this function using power rule, which will be the minus 0.36 divided by r squared plus 112 pr. And to find the stationary point, we equal our derivative to the 0. So it will be minus 0.36 divided by r squared plus 112 pr equals to 0. Then we can find our radius, which is 0.1008 meter. Found the radius, we can find the height. So the height will be 0.010 divided by p, our radius, p multiplied 0.1008 square. So our height will be 0.3133 meter. So then we should find, is our stationary point maximum point or minimum point? To find that, we should test our function to concavity it. To do this, we should find our second derivative. So the second derivative of the function will be, using also the power rule, will be 0.36 divided by r cubed plus 112p. Then we found our second derivatives in terms of our radius. When the radius will be 0.1008, how much will be our second derivatives? So we just substitute into our second derivatives, so which will be 0.36 divided by 0.10083 plus 112p. So the answer will be 703 and 36. So this one is more than 0, which is our concavity will be like this, and our point will be here, which is minimum point. So our radius is stationary minimum point. Let's move on to the second part. Now we have our radius and our height, so we can find the areas of the sidewall and areas of the end caps, which is formula of the area of the sidewall is 2p rh, which is 2p our radius multiplied by our height, and the answer will be 0.1984 meter square. And formula of the area of the end caps will be 2p r square, which is 2p multiplied by square our radius, which is answer will be 0.06384 meter square. Then we can already find the minimum cost, which is our cost of the sidewall is 18 ringgit and the cost of our end caps is 28 ringgit per meter square. Then we multiply by our areas, and the answer will be 5 ringgit 36 cent, which is minimum cost of our cylindrical mailing tube. Then if we raise our cost of the end caps from 28 to 35 ringgit per meter square, and cost of our sidewall remains the same, which is 18 ringgit, how our values will be changed? So to find this, we again find our function, which is CR equals to cost of sidewall multiplied by area of the sidewall plus cost of the end caps multiplied by area of the end caps, which is 18 multiplied by 2pr 0.010 pr square minus 35 2pr square. Then we differentiate this function using power rule, and the answer will be minus 0.36 divided by r squared plus 140 pr. If we compare with the first part, this part remains the same because we have the same cost of the sidewall. But this part is changed because in the first part it was 112 pr. Now we have 140 pr. Then to find our stationary point new radius, equate our derivatives to the 0 and then find the radius. The new radius will be 0.09354, which is less than the old one. So what conclusion can we make? If we raise the cost of the end caps, which will be the expensive part of our mailing tube, To minimize the cost, we try to reduce our radius, but to reduce the area, we should reduce the radius because area depends on the radius. So if we also reduce the radius, we should increase our height to remain our fixed volume unchanged. Yes, so that is why our mailing tube will be thinner and higher. That's all, thank you.
In task 2, white block on the billboard, we have a billboard with a height of 5 meters and also height of 4 meters, which is measured from the bottom edge. Also, given that, we can write this value as a B and H constant. So, also we have idealized one pressure equation which will help us to determine the total force in newtons later. So, this equation is height dependent, so this limit will be applied in this stage and also this stage. Because our height of the billboard is from 0, starting from 0, so this one will be our 0, and the end of it will be 4. So that's why it's height dependent. So also we have this value for our P0 and K value, which is 40 newtons per meter square, and also K value is 12 newtons per meter cube. So first part, we should calculate its total force in newtons. Second is center of the pressure, and also compare center of the pressure when pressure is uniform. So let's start with calculation. Let's discuss what we have and what should we do. So in this first part, we need to find the total force in newtons, and here we have a formula in our task, which we will use. So for the first part, we can just simplify it a bit. So just move P constant in front of our integral, and then substitute our Py in terms of this equation. So we will get just P0 plus Ky dy. So after that, we can just integrate it by using basic integration formulas here. So for the P0, which is our first part, we will use the third formula, which is just constant multiplied by x. So here we will have Ky, which is our second part, and we will use this formula. So we will get just Ky in the power of 2 divided by 2, as well as for this part. So here we need to just substitute our constant and values. For our B, it will be just 5 meters, and for our H, it will be just 4. For our P0 and K value, we need to just substitute these values given to us in our task. So we will get this equation. So before the next part, we need to discuss about this formula. So our B will be our H, and our A will be our 0. So we need to just use this formula and we'll get these two brackets here. So our first bracket will be our B and our second bracket will be our A. So let's just substitute all the values with all the units here. So we will get this equation. So our second bracket will be just 0 because here is 0 and we should just multiply everything by 0. So here we will get just 5 meters multiplied by bracket where we have 160 newtons per meter with 96 newtons per meter. So by calculating it, we will get just 1280 newtons in this part. So it will be our final answer for our first part to find the total force in newtons. Okay, so start with our second part. We need to find the height of our resultant force, which is acting on our billboard. So here we have to find center of the pressure. And we also have this formula which will help us with that. So let's just divide it by two parts, first and second. For the first part, we need to just apply the same method as before. We can just move P constant in front, also substitute Py in terms of P0 plus Ky dy, and just integrate it by using the basic integration formulas before. So by integrating it, we will get just P0 and y in the power 2 divided by 2 plus Ky in the power 3 divided by 3. So it will be answer for our first part, not the answer, just an equation for our first part, and for the second part we need to do the same. So we'll just move P constant in front, also substitute Py in terms of P0 and Ky, and then just integrate it by using integration basic formulas. So we will get this part here and just write it here. So let's just focus on this part. So to continue with our second part, we can just use this part that we calculated and integrated before. Then just apply our limits here. As you remember, as before, our second bracket will be just 0 because our limit had the 0 inside it. So here we can just use our values, which is also located here, and then we will get just two brackets. The first one, by summarizing it all, we'll just get 576 newtons divided by 256 newtons per meter. So then we can just cancel newtons here, and we will get 2.25 meters, which is just slightly higher than our middle point of our height of the billboard, which is 4 divided by 2 will get 2. Okay, so let's discuss about our last part. So here we have equation which states that our pressure should be uniform or constant. In that case, when our pressure is constant, it the total pressure will be evenly distributed across the board and mostly act on the midpoint of it. So it will be about 2. How we can find it? As I said before, we can just divide our height by 2 and get our midpoint. So in our case, when our pressure is not uniform or constant, our center of pressure will shift upwards because it height dependent. So when our height is increased, our pressure will also increase. So here we can say that the most pressure will act on the edges of our billboard.
So let's solve the problem number 3. We have the algorithm for the reducing of error in the each cycle, and we have initial error, which is 5%, and we have converted it into the number value. After that, we need to find the integer value so that the final error is going to be half of the percent, which can be expressed as 0.005. Then we are going to write it in the inequality form, which is going to be our formula and the final value that we want to reach. At the same time, we can already insert the values that we have, which is the initial error. We already have the percent of the reduction of the error, and we need to find n. In order to find the n, we need to put it down from the power. So we are gonna take the natural logarithm from both sides, which is gonna be equal to this form. After that, we need to consider the fact that the values inside the natural logarithm is smaller than 1, which means that they are gonna be in the negative value. After, we need to change the position of the natural logarithm and switch the signs for this reason. Our final value is going to be higher than 4.5, and the nearest integer value of n is going to be equal to 5.
So now we move on to the task 3, part 2. In this part, we need to improve the design that we already used, and now we introduce a boosting algorithm that reduces our error by 70% with the first 2 cycles, and then it reduces our error by 60% after the first 2 cycles. So our main goal is total error should be less than this value, because we need to express this 0.5% error in fractions and not in percent. And in order to express the nth term of our error, let's try to think, what is this e? And if you think about it, our error reduces by some percent each time. So we multiply our error by a certain number, which means that this set is actually geometric series. And this means that we need to multiply it firstly by our initial error, which is equal to 5%, and then we multiply it by 1 minus 0.7% because our error reduces by 70%, and again we need to express it in fractions and not in percent. And in the end we'll get this expression. And note that we also need to put the power of n since we multiply each error by a certain percent, and this n represents the number of times we multiply this error by a certain percent. Stage 2, same thing, but this time error reduces by 60%. And for the initial value, we'll take the E2. E2 is the error that we obtained after the first 2 cycles, which we will need to calculate here in the stage 1. And then 1 minus 0.6 power of n, and then we'll get E2 multiplied by 0.4 power of n, where n is more than 2. But then, interesting thing happens. If we look closer into the stage 1, where n is equal to 2, we can see that our error is actually 0.0045, which is already less than the error that we need to beat. And this means that we only need 2 cycles to overcome this error. Now we move on to the task 3, part 3. In this part, we'll need to calculate the time that is required for the overall optimization cycles that we'll need to compute. So we'll need to take the n that we got from task 1 thanks to Aisuluu, and the n is equal to 5. This is the number of cycles that we need to compute in order to optimize our process. After that, we know that our initial time is t equals to 20 minutes. It becomes 10% faster with each cycle that is happening in our optimization, which means that this 20 minutes with each cycle, the time that is required for 1 cycle, it will reduce by 10%. In order to express it in fractions, we can say that each time our t will be multiplied by 0.9, which is 1 minus 0.1, where 0.1 represents 10%. And this means that the first 20% will be our initial value. Next time, we will need 20 multiplied by 0.9 in order to compute the second cycle, and 20 multiplied by 0.9 multiplied by 0.9 to compute our third cycle. And from this pattern, we can say that this is the geometric sequence. And the general formula for the nth term of the geometric series looks like this, where an is the nth term, a1 is the first term of the sequence, and r is the number that we multiply with each step, and n is the number of steps. So we already know that our n is equal to 5. Now we need to express our tn, so the nth term of our time, and this will be t1 multiplied by 0.9 multiplied by n. We know that t1 is equal to 20, and then n we just leave like that for a few seconds. In order to express the geometric series that we need to calculate to find the overall time that we need for this optimization cycle, we can use the sigma notation. But since we already know that it is a geometric sequence, we can simply use the formula that calculates the sum of the geometric series, where a1 is our first term, which is 20 minutes, r is the 0.9, and n is equal to 5. So by substituting all these values, we can get the 81.90 minutes, which is our final answer.